One line of Python can turn slow functions into instant ones. Let me show you the hidden cache trick. Hello coders, welcome to my channel. I'm David, your guide to mastering programming. To improve the speed of functions, I first need to show you the limitations of them. And I will do that on a very common sequence called Fibonacci sequence. The sequence starts with numbers 0 and 1, and every other number is calculated as the sum of previous two. So the next will be 1, and the next will be 2, 3, 5, 8, 13, and so on. To code this function, I will use recursion. Recursion is a simple function that calls itself, and you will see how. I will call mine fib. It will get the parameter n, which will tell me exactly which number from the Fibonacci sequence I want. For example, the first, the second, or the fifth number. If the number is 0, then I want to return 0. If the number is 1 or 2, then I again want to return 1. But if it's any other, then I want to call this function with this formula. Return fib n minus 1 plus fib n minus 2. As you can see, I call this function twice, which means for every call, I will have some separation, and this function will spread. Now, if I call print fib of 10, this should print 55. As you can see, it printed 55 instantly. But if I run this on 40, you will see how much time I will need. As you can see, it took some time, and I will show you why it took that much time. First, I will create first 5 or 10 numbers. 0, 1, 1, 2, 3, 5, etc. This will be the position 0, 1, 2, 3, 4, or 5. I will not look into this number, just these two will be my base ones. Now, if I want, let's say, to get this number 5, first 5 will be called. After 5, 3 will be called, then, and 4 as well. After 3, 1 will be called, but I know the value of 1, so this won't spread anymore. Then 2 will be called, but I also know the value of 2, so not the value of 2, but the value of the second element, so this won't spread anymore. This will be also 2. Yes, I know the value of 2, so this won't spread anymore. Then 3, I don't know the value of 3, so this will spread. To 1, I know the value of 1, so this won't spread. 2, I know the value of 2, so this won't spread. The value of the first element is 1, the value of second element is 1, so we can fill all of these. Now, how we calculate the position of a parent, we simply add these two. So now this will have value 2. And as you can see, the third element has value 2. And if you check here, indeed, the third element has value 2. Here 2. Then the fourth element will be the sum of these two. It will be 3. And indeed, the fourth element has value 3. And the fifth element will have value 5. And that is the number that we want, 5. As you can see, to get this fifth element, it took me this many recursive calls. It spread too much. But most of them I already know. For example, these 3 I already know. And I could skip this if I just put 2 immediately here. To solve that, in programming, we use something that's called memoization. Python has that built in, so you then don't have to call the memoization yourself. You can simply, from function tools, import something that's called LRU cache. This is a decorator which gets the parameter max size, which tells how many function calls you want to remember. For example, you can write 10 or you can write none, which means there is no limitation. It will grow infinitely. And now, when I run this, but I forgot to print at the rate sign. Now, when I run this, you will see that this Fibonacci of 40 will print the solution instantly. As you can see, as I promised, the solution is printed instantly. If you like this video and you want to save even more time, check out my video on 5 Python functions you wish you knew sooner. And don't forget to subscribe. See you soon.